What I've got here today is the second one of the Fluke scope meters, the 96B. This is the working one. They're missing their rubber overmolds because they were perished, and this one has never had a battery since I owned it. This one I've removed the battery because it had obviously failed, and the inside of the compartment had purple and blue crusties inside it. So this second scope did not power up when I got it. Now Philips originally made these scopes for Fluke in the 90s. They're nicely made, that's why they were so expensive, and they are. And a full service manual is available. So I started off by checking whether there's voltages, because that's where you start when a thing doesn't want to power on. Have you got your voltages? And the way this thing works is you've got this circuit over here called the RAM power. It's a charge pump, because the way this thing works is the power supply actually lives at minus 8.4 volts. It's a negative system. So your battery actually forms the negative rail of the split rail power supply. So your positive, one of your supplies for your positive rail, your plus 5 volts, your RAM power, comes in this charge pump. So what you got over here is a classic oscillator circuit. There's an inverter. You got your capacitor and your resistor, and the output from the inverter, which produces current through the resistor, charges it, and then once it's charged up, that pin comes up. Once it's over the threshold, that goes low. This thing discharges the capacitor till that pin is below the threshold. The output goes high again, and so it oscillates, and that's running at about 1 kilohertz. It then uses the remaining 3 comparators as a buffer. These are Schottky diodes over here, BAT545s, and it's coupled to them through a capacitor. And then over there's your output to the there's your 5 volts that's generated. So what happens is, when the output goes negative, current flows to that diode, and it charges up that capacitor. So that's what happens when that pin goes low. When the pin goes high, current flows through that diode, and it charges up those capacitors over there and generates your 5 volts. So the energy is stored over there. So that's your 5 volts over there. It's called VRAM. Now the on-off circuit comes from the keypad, which is over here. Use your on keypad, and over here is your on-off circuit. So when you push the button on the membrane keypad, current is drawn through that transistor, and it latches that one on. And then once again, when you want to turn it off, when you push the button again, it turns it off. Now what is happening is this thing was not turning on, and when I had a look, it turned out I wasn't getting a signal from here. So this is out of the service manual, a 250 page document, which is freely available. It's nice and it's well written. So this is for a similar scope, but the architecture is the same, and because of that I was happy to use just as part of the drawing. This is the overlay for the board. There's 3 pages to it. And then over here there's a description of the circuit. The on-off circuit operates almost like a thyristor. When the on-off key is pressed, the current is drawn from the base of V1503. Let's put these aside. Bring that back. 1503, so it draws current through that base of that transistor via 1503 and 1501. 1501. Get them. Okay. And they've shown them as so that's 1501, 1502 and 1506. The signal power on will now become high. That signal over there, on off, so that transistor goes into conduction, and the signal goes through here to the rest of the thing to tell it that it's on. That's high. The on-off switch will go high, turning off V1506 and 1503. The next time the on-off key is depressed, the on signal will become low and the scope meter turns off. So that's the circuit which stops and starts it. So over here you got your CMOS backup battery, which is still measuring 3 volts amazingly. It's a Renata battery. That's obviously the good stuff. So this thing is covered. The exterior of the case inside the battery compartment, it is absolutely filthy, and it's sort of a brown tar-like substance. We all know what that is. So what had happened is that this little conductor pad was not making contact with that when you push the button, and I thought, oh dear. But what happened at first is I was poking around with the scope probe on these connections over here, and when you examine this you can follow the tracks and see where they come up here, so you know what's going on. With a scope probe, I knew that the I think it's 8 volts. The minus 8 volts is present. Let's show you that. Try not to cause an avalanche. That's that over there. You can see the minus 8 volts. see if we can move the scope. What we need to do, put the scope over here, like so. Yeah, I think it's in shot. So there's the -8 volts. And now what happened is when I put the scope probe across those two pins, there's a buzzer, it powers up. Thought, nice, it means we've got a working scope. So the problem's here. So over here's your on-off key. Now that's what it's supposed to do. It was not doing it. Nothing happening. So I obtained some of these swabs and some cleaning fluid, IPA, and I cleaned that little pad, and I cleaned over here, and this pad started working again. So obviously what has happened here is that that stuff in the air has coated that pad and stopped it from working, and just cleaning these is going to restore operation of this pad. Because if we have a look, put scope away, gonna. I think it's powered up at the moment. Yes, it is. I can now start looking at a few other things. Cursor readings. Meter. Okay, nice. So it doesn't look as though we got any bad areas here on the LCD. Is he mean contrast? So what I'm going to have to do is I'm going to need to wash this and get it cleaned up. Yeah, the buttons are not working correctly yet. Let's see if the backlight works. Interesting. I'm not too worried about the backlight. I'll have to check this out. So this needs a wash. This thing can't really be operated all that nicely with it in pieces. What I need to do is get it reassembled. So the shield has to go back, that covers this area. It has had a really hard life. I was using that as 0 volts. Put the scope away. The thing has had a hard life. There's more of this brown stuff all over it. Unfortunately, that BNC over there has got a broken outer part, so I may have to look at reworking that. Now the problem is that something got put over the area where these screws are, some kind of glue. I don't know if that was sealing it from calibration or what on earth happened there. I don't intend to use this with batteries, fortunately, because I use it at the desk. So the net result of those screws being sealed like that is that this looks like this. So that's going to need a little bit of cosmetic work. But I do think we got a shot at a working scope here, which is nice. This was a second one which was available from the scrap pile, and it wasn't turning on, and it looks like it's just the rubber keypad. So what I need to do, take this guy over here, get it washed, get all the contact pads cleaned up, reassemble it, then and test the scope out and see how the rest of it is. But I think there's a good chance that we got a good scope, or even just a decent multimeter out of it. I'd be happy with that as well. So that's my current project, is getting this scope back to life, which is nice, because if that happens, it's valuable. It's a useful addition. You can never have enough of this stuff. So this is part 1 of the restoration of the Fluke 96B scope meter. Thanks for being here for this today, ladies and gentlemen. It has been a while since you saw me previously, but then this is my hobby. I don't earn a living out of YouTube. YouTube is actually not something I want to do as a career. It consumes one, as they say. Doing it as a day job was a terrible thing. The people who do find it very hard, and it's actually very complicated and difficult running it as a business, and you can't do it alone. Yes, it's like that. So this stays my hobby, and as and when I want to, I upload stuff. It's like that, which is fine. It's better for me, and when I have stuff available, you guys get to see it. So that's the story. I'm going to end it here. Thank you, ladies and gentlemen. Have an awesome day further. I've waffled on here, so I'm going to carry on. Take care of yourselves. See you here next time for possibly the next part of the scope restoration. Alright, cheers.